You should be familiar with the following concepts from pre-calculus for this lesson. So we've talked about vertical asymptotes before. You've seen them in pre-calculus when analyzing a graph. Certain trig functions have vertical asymptotes, such as the cotangent function seen here. A horizontal asymptote is kind of the inverse of that, where the x values are growing without bound. We're looking at the limit as x approaches positive or negative infinity, and we're seeing how the function behaves when that happens. So the most basic rational function is 1 over x. And when we graph that, we see that it has a horizontal asymptote at y equals 0. So as I travel along the x-axis to the right or to the left, I see that the graph is approaching the line y equals 0, which is the x-axis. So the reason this happens is because the denominator is growing. X is going from 2 to 3 to 4 to 5, etc. And of course all numbers in between. And yet the numerator is staying constant. So when that happens, our values are getting smaller and smaller as the denominators get larger and larger. And we say that the limit as x approaches infinity of 1 over x is 0. And notice that the equation of the x-axis is y equals 0. So that is no coincidence. Here's the official definition for a limit at infinity. So the limit as x goes to infinity of some function is some value L, or as limit as x goes to negative infinity of a function is some value L. And that line y equals L is the horizontal asymptote of the curve. You have seen horizontal asymptotes before when you've studied exponential functions in the past. So this is the graph of e to the x. Notice that as we travel down along the negative x-axis, this function is skimming along the x-axis, so again y equals 0. So here are a couple of transformations of the exponential function. So this graph is e to the x. This dashed graph is 3e to the x plus 4. And you can see that recall what that plus 4 does is it takes the graph and shifts it up 4. So it makes sense that that is now the horizontal asymptote. Also notice I have graphed here f of x equals e to the minus x. And the limit as x goes to infinity of e to the minus x is 0. So the limit as x goes to negative infinity of e to the x is equal to the limit as x goes to positive infinity of e to the negative x. It makes sense. We're just flipping that graph over the y-axis. So you may recall that rational functions may have horizontal asymptotes. Here's an example of a rational function. And when we graph it, we see it has a horizontal asymptote at y equals 1. And the reason that occurs is, if you remember doing polynomial division, this rational function is really just the result of dividing x squared minus 1 by x squared plus 1. So when we perform that division, the quotient is just 1, and this is the remainder, minus 2 over x squared plus 1. So as x gets larger and larger, this denominator grows. So as x gets larger, we travel along the right or the left of the x-axis. This remainder is approaching 0 because this denominator is growing and growing, but the numerator is staying the same. So that's why this function is approaching 1 as x approaches infinity or negative infinity. A function can have two horizontal asymptotes. Here's an example. It's kind of a weird function. Here's a more common function that has two horizontal asymptotes. We have a rational function like this where the numerator and denominator are of the same degree. There's a little trick we can do that's kind of a shortcut to actually performing the division and to find the quotient, because like we saw before, the horizontal asymptote is the quotient, and the remainder is what's going to 0 as x goes to infinity. So we don't have to go through the polynomial division every time. We can use this shortcut. So since x is going to infinity, and minus infinity for a horizontal asymptote, we can perform this trick of multiplying the numerator and denominator by 1 over x. We don't need to worry about x being 0 because it's going to infinity and negative infinity, so we can do this. And when we multiply the numerator and denominator by 1 over x, we see that we have 5 over x plus 4 divided by 1 plus 3x. And as x grows to infinity, these two denominators get large. The numerators are constant. So these two values go to 0. And this gives us a limit of just 4 over 1, or 4. The same thing here with x going to negative infinity, of the same limit. And I can see then that the horizontal asymptote's y equals 4.